Okay everyone, how you doing today? This is the Bridge for Math, Dr. B. This video tutorial is really geared at getting you prepared for a new function. A function called a logarithm. Now some of you might have heard of logarithms, some of you may have never heard of a logarithm, but this video I'm going to show you insight and pretty much what I think is important to know. So let's come over here to this side of the board. Function. You know that F word in math, so many F words. Function, what comes to your mind when you think of function? Well, I think of a function as I have an input, I put into this machine called a function, and I get out an output. So let's look at how this relates. Do you remember the notation for a function? F of x, F for function, that's the name of the function, F. Parentheses x tells you that's your input, an input x, equals an output. Well, what's your output? The log tells you, defines your function. Log stands for logarithm. The subscript b is your base, and I'll describe that a little bit later. Your x happens to be the input. Do you remember when you had a function, you put in a number in wherever you saw an x? So you have a function, f of x is log base b of x. Well, with functions, do you also remember f of x was equivalent to the value of y, your output? So notice here I put y is your output equals a function, a logarithmic function. They abbreviate it with log. And most math books will put it as lowercase l. So make sure you make a note of that. Lowercase log. Some people get confused and think it's a 1. And you have an input x. Now it turns out your function, your logarithmic function, that base b is very important. It kind of tells you a lot about what that function's like. I want to give you an analogy. Do you agree there's a lot of different lines, different slopes? Well, what kind of tells you a lot about a line? Its slope, and also its y-intercept of it, things like that. Well, logarithm, what tells you a lot about a logarithm is its base. Go to a calculator, if you have a scientific calculator, or your cell phone, look for your scientific app, for a calculator app. You'll likely find a button that has log. Now, you might also notice that there's no base. There's no base. Well, most calculators, when they have log, are assuming something called a common logarithm. They're assuming a common logarithm. They don't even show you a base. You're probably going, well, one's a common logarithm. Well, what's an uncommon logarithm? Well, I'll give you an answer. Anything that's not a base 10. Common base. You'll see another button called ln, and you're going to learn a little bit later that's called a natural logarithm. It has a base that's equivalent to 2.718, which is called Euler's constant, E. It's just a value, 2.718 is your base. But before we go there, I'd like to see if you can see a pattern. So right now, even if you've never understood anything about logarithms, it's my money-back guarantee that when you leave this video tutorial, you'll be able to answer some really good approximations for logarithms, even without a calculator. So log of 10. What's my input? 10. Put it into my logarithm machine. What do I get out? A 1. Okay, let's try again. Log of 100. I get out a 2. You might, when I say a pattern, does it mean it doubles? Let's keep going. Log of 1,000 equals 3. Oh, it's not doubling. What's happening here? But you have enough points, maybe you can see a pattern. Log of 1,000,000 equals 6. Yeah, I know a lot of you brainiacs out there going, oh, I see the pattern. It appears to be the number of zeros tells me the answer to the logarithm. So log of 1,000,000, you have 1,000,000 as your input, and what comes out? A 6, a small number. So often I'll call logarithms the things that take down big numbers and make them small. So here's my conclusion. The number of zeros is the answer. Not quite that easy, so let's take it up a notch. I told you earlier at the definition of a logarithm that logarithms as a function have a base. In this case, let's call it base 10. Because base 10 is a common logarithm, the ones that are used most often in application along with the natural logarithm. So let's look at this. What's 10 to the 1 power, or 10 to the 1 exponent? It's 10. What's log base 10 of 10? It's equal to 1. Now notice, everyone, I rewrote this over here slightly different. Did you notice any differences? One, did you notice here I used the capital L where math books usually put a lowercase l? I tend to put capital L so you remember it's a logarithm. Another thing, over here, did I have a base? No. And a lot of times people will just say a logarithm without a base, and you just have to assume it's 10. But here I wrote it down specifically. And instead of putting 10 by itself, here I put 10 to an exponent of the 1 power. It's equal to 1. So what is 100? It's also known as 10 squared. We're an exponent of 2. Well, log of 10 squared with base 10 is 2. What is the 10 to the third power? It's 1,000. Log of 1,000 base 10 is 3. So I've rewritten it the same way as we had over here where you had a pattern. But instead of saying the number of zeros, what could you say here as a conclusion? Oh, the answer to a logarithm, a common logarithm, the exponent is the answer. And you'd be correct. You would be correct. And books, and if you went to Wikipedia and other places to try to figure out what a logarithm is, they say a logarithm is an exponent. And I hate that definition. That's why I'm giving you this video tutorial so I can give you some more clarity. But it is a true answer. But let's see if you can get some more understanding. I feel this relationship, a very useful relationship, is the best way to understand logarithms. The best way, in my opinion, to understand logarithms is to see how it compares to an exponential equation. What is exponential? Exponential is when you have an exponent. So you got to look at this. If I went up to you and said 10 squared, and I said 10 squared equals 100, that would be an exponential equation. But here is a relationship. I have a double arrow here, which means it's equivalent. So we have our logarithm of a base b. Notice color theory here too. I try to use color to get you to look at specific areas. This is bad boy blue for my base. I got money, CeeLo green is my x input, equals sexy red y. So look at these colors. It's equivalent to this same base raised to that power equals x. Sometimes I draw an arrow here so you see it. But b to the y equals x is equivalent to log base b of input x equals y. They're equivalent. Now, if logarithms are new to you, this would feel uncomfortable, but this might feel very natural to you. Let's look at an example to see if you feel better. 10 cubed. 10 cubed equals 1,000. You're like, yeah, I get that. Well, let's rewrite it from exponential form into logarithmic form. All you have to do is see 3 puzzle pieces. Bad boy blue, 10. What does 10 represent? Exactly, my base. What does the 3 represent? That y value, my exponent. And what's the 1,000 represent? The x value, which happens to be my input for logarithms. So those 3 puzzle pieces are the same in both of these location forms. They're the same. So I'd rewrite this as log 10 of 1,000, and do you remember what's that equal to? Yeah, you're leaving here this video, you know log of 1,000 is equal to 3. So this is how I feel the best way to understand what a logarithm is. It's another way of looking at an exponential form. They're equivalent. Logarithms take big inputs and make them small. Exponential functions take small inputs and give you a big number. You're going to find out that exponential functions and logarithmic functions are inverse functions. That's another video tutorial. But right now, let's make sure you really feel good about a logarithm. Let's talk about it one more time. A logarithm is a type of function. A logarithm is defined by its base. What are some things we know about a base? Well, the base has to be greater than 0, which is a fancy way of saying that base better be positive. So think positive, some number bigger than 0. The base also cannot equal 1. Now, why do you think that would be the case? Why should the base not equal 1? 1's positive, why can't it equal 1? The best way to look at it is in equivalent form. When you have an exponential, what is 1 raised to any power? 1. Hence, it's meaningless. So the base not equal to 1, I like to say it's not equal to 1 based upon its exponential equivalent. What do we know about our input x? Well, I'd like to challenge you to get your calculator or cell phone and do this application. If you put in a negative number for your input, you're going to see an error. Turns out x has to be, your input x has to be positive for a logarithm. Now, what about the y? What can a logarithm equal? If I take the logarithm, what things does this machine put out? this machine will put out things that are negative, 0, or positive. So your y value can be anything. So I hope that you see the different puzzle pieces. You know that the y value can be anything. You know that the input has to be positive. And you know that your base has to be positive. So this is Dr. B coming at you, the Bridge for Math. I hope this gives you the foundation for tackling logarithm questions. We're going to be doing more of these logarithm tutorials. Come check me out at YouTube.